Good evening. Today we are going to present about the mode of operation. So, Suan, can you start by explaining about ECB? I've heard it's one of the simplest mode. So I want to know about what makes it so basic.
Okay, also ECB is the simplest and most straightforward mode of the operation for block cipher like DS or AS. Each plaintext block is encrypted independently using the same key. However, its simplicity comes with significant security drawbacks, as pattern in plaintext can be reversed in ciphertext. This lack of randomness makes it vulnerable to pattern analysis attacks.
So would you say ECB is secure or sensitive data?
Not at all. It's not suitable for encryption of sensitive data. ECB is efficient but shouldn't be used for sensitive data. It's great for things like encryption random access memory data where security isn't the highest priority. So I will talk about the counter mod. Next, the counter transforms a block cipher into a stream cipher by using a counter value to generate a key stream. Each block of plaintext is exclusive or with a unique key stream for encryption. CTR is efficient, parallelizable, and well suited for modern cryptographic applications. Okay, so Eddy, what about the CBC? I hear it's used a lot in practice, but how does it differ from EBC, ECB?
Okay, great question. CBC is also known as cipher block chaining, improve security by using a chaining mechanism. Each plaintext block is XOR with the previous ciphertext block before encryption. This makes it so that identical plaintext produce different ciphertexts, which is a big advantage over ECB. And initialization vectors is used for the first block to ensure randomness. This process ensures the identical plaintext block produce different ciphertext if different initialization vectors are used. So this is the table I have done. As a summary of this table, CBC offers strong security by ensuring identical plaintext block produce different ciphertexts, enhancing confidentiality, provide the initialization vectors is used correctly. Its chaining mechanisms strengthen its security by linking blocks, but this create dependencies as decryption requires the previous cipher blocks, limiting flexibility. Errors in one ciphertext block affect only two plaintext blocks, reducing overall disruption through partial data corruption can occur. While decryption can be parallelized, encryption is sequential, making it less efficient for large-scale operations. Hayden, you have got the trickiest ones, which is the CFB and OFB. Can you start with CFB?
Sure, Eddie. CFB is an AS block cipher mode similar to the CBC mode in the sense of that for the encryption of a block, the cipher of the previous block is required. It fits the ciphertext back into the encryption process, so each block depends on the previous ciphertext and this provides strong security. This ensures different ciphertexts for identical plaintext like CBC. For chaining dependencies, strong avalanche effect provides better security. However, if there's an error in one ciphertext block, it affects all subsequent blocks. It can also resynchronize after a small data loss or corruption in the ciphertext. So next about the OFB, it's like CFB cousin. It is a mode of operation for block cipher that transforms the block cipher into a string cipher. It uses the output of the encryption process, making it independent of the plaintext and ciphertext. In OFB, each will produce different ciphertexts for identical plaintext blocks, and this ensures the security of this mode. Then, for its chaining dependency, OFB only depends on the previous encrypted output block. It also has the minimal error propagation because it only affects the corresponding bit. For its efficiency, it has a good efficiency because it can pre-compute the key stream. Yeah, that's all from me.
Okay. Since the time is limited, I have concluded all the points in a comparative table, so viewer can just pause the video to view the table. So that is all from our group. Thank you.
Yeah, thank you.